faculty members, dear students, we will start today's session with a prayer. I request Sabyasachi to render the prayer song.
Om Sahana Bhavatu Sahano Bhunaktu Sahabiriyam Karvavahai Tejasvinavadhitamastu mam Vidvishavahai. Om Brahmananda Paramasukhadam Kevalam Jnanamurtim Dvandatitam Gaganasatrisham Tattvamasyadilaksham Ekam nityam vimalachalam sarvadhi sakshi bhutam bhavatetam trigunarahitam sadgurum tvam namami. Om akhanda mandalakaram vyaptyam yena characharam tatpanam darshitam yena tasmai shri guruve namah. Guru Brahma Guru Vishnu Guru Deva Maheshwara Guru Deva Parama Brahma Tasmai Shri Guruve Namah. Ajnanatimirandhasya jnananjana shalakaya chakshurunmilitam yena tasmai shri guruve namah. Om priyatam pundarikasham sarva papahara hari tasmin tushte jagatushtam pranite pranitam jagat. Om sarvesham mangalam bhuvat sarve santu niramaya sarve bhadrani pashyantu ma kaschit dukkha bhaga bhave. Om Shanti Shanti Shanti.
Thank you, Sabyasachi. Respected Director, respected Professor K. Ramasubramanian Sir, Deans, Head of Departments, faculty members, students, ladies and gentlemen, good evening to all of you. Today is a very important day for us. We have the first offline session on important topic of Indian knowledge system, that is contributions of Kerala to the world of mathematics by Professor Ramasubramanian sir. Indian knowledge system. Our director has established 11 centers known as multidisciplinary centers on various aspects. And one such center is the Center for Indian Knowledge System. And in the month of April, we had organized the first lecture, online lecture, by Professor B. Mahadevan sir, who has recently authored a textbook on Indian knowledge system, concepts and applications. That was an online session. This is the first offline session. And I'm sure this session will be very interactive at the end of the session. And this will also give an opportunity for us to know about the contributions of our people to this science, mathematics. When you say Indian knowledge system, the term Indian means the indigenous sources of knowledge. In fact, the term Indian points to the undivided Indian subcontinent, which we call as Akhanda Bharata. And the knowledge actually is synthesized, codified and made available by the Indians. And this knowledge is in the form of tacit knowledge. It primarily arises in the form of wisdom of the knowledge seekers. It is obtained by the insights gained by personal experiences with life situations, facing problems and coming up with means of solving them. The tacit knowledge gained by a seeker is eventually transmitted systematically in the form of some explicit knowledge. This happens by way of proposing a new theory, framework, or literary work. By system, we mean a structured methodology and a classification scheme to access the available corpus of knowledge. By its inherent nature, knowledge could be accessed in any manner depending on the interest, purpose, and capacity of the seeker. For an uninitiated, this vastness could throw a challenge, as the seeker may be clueless as to where to begin and how to proceed. Therefore, the available knowledge needs to be collected, grouped, and arranged logically. Codification and classification of the available knowledge using a definite framework would constitute one dimension of the word system in Indian knowledge system. The other important requirement is the interconnection between the part of the knowledge in the classification framework. The framework used to represent should also provide some logical relationships between the different parts of the proposed framework. So, the Indian knowledge system, the knowledge has been acquired through introspection on various aspects. In fact, when you say the Indian knowledge, we refer to the 14 branches of Indian knowledge, starting with the 4 Vedas, and then the 6 Vedangas, and then the 4 Dharma Shastras. So 14. And in this, mathematics forms very important part, that is in this Vedanga, that is Jyotisha. Jyotisha consists of 3 sections, that is known as Siddhanta, Hora and Samhita. Actually, the astronomy and astrology are 2 parts of this Jyotishastra. Astronomy examines the position of the planets and other heavenly bodies. It does not concern itself with how they affect the life of the world or the individual. It is not its function to find out how far the celestial bodies are beneficial to us or how they may be made favorable to us. Such functions belong to astrology. And Jyotisha includes both astronomy and astrology. Let me just say a few words about the mathematics part in Indian knowledge system, which is going to be elaborated in detail by Professor Ramasubramanian sir. Arithmetic called Vyakta Ganita in Sanskrit includes addition, subtraction, multiplication, and division. Avyakta Ganita is algebra. And Jya means the earth, Miti is the method of measurement. Geometry evolved with the need to measure the sacrificial place. Geometry is derived from this word. The geo in geography is Jya. There is a mathematical exercise called Samikarana, which is the same as equation. So these are all several aspects of mathematics, and this astronomy and astrology full of mathematics only. And our Ramasubramanian sir has done a lot of contributions in this area. And he holds a doctoral degree in theoretical physics, a master's in Sanskrit, and a bachelor's in electronics and communication engineering. A formidable combination with which he has re-established some of the lost treasures of our ancient Indian knowledge traditions. He has several honors and awards. The most important one is the Vidvat Pravara, which is awarded by Sringeri Shartha Peetham for the successful completion of 14-semester program in Advaita Vedanta. Then he has been awarded several awards. Maharishi Badarayana Vyasa Samman by President of India for his contributions towards synergy between tradition and modernity. R.C. Gupta Endowment Lecture Award by Indian National Academy of Sciences for the promotion of history of science in India. Then Visiting Erskine Fellow by the University of Canterbury, New Zealand, invited for collaborative research work. Then Madhava Ganita Puraskar by Madhava Ganita Kendram, Irinyalakuda, for bringing to the fore the contributions of Kerala astronomers. He is a fellow of Indian National Science Academy for the contributions to the field of history of science. And IIT Bombay has awarded him as Research Dissemination Award for authoring monographs in Indian astronomy and mathematics. He was awarded Satish Bhatnagar Award by the Indian Maths Society for best paper on the history of mathematics, and he has several contributions, and some important things I will highlight. Just a few things, sir. Few things. He has published 3 books. One is titled as Ganita Yukti Bhasa, Rationales in Mathematical Astronomy, in 2 volumes. Then Tantra Sangraha with detailed mathematical explanatory notes. Then Karana Paddhati with detailed mathematical explanatory notes. Then he has published several edited volumes on different topics, like 500 Years of Tantra Sangraha, a landmark in the history of astronomy, Ganitananda, then History of Indian Astronomy, a handbook, then Bhaskara Prabha, then Studies in Indian Mathematics and Astronomy, then Ganitananda. And he has 3 pioneering research monographs, 6 acclaimed edited volumes, and 2 best doctoral thesis awardees. One in 2013 and 2019. Then the last one, very important contribution is he has launched the Science and Heritage Initiative in IIT Bombay, that is known as Sandhi at IIT Bombay. And he has several research publications. In fact, I had mentioned that he has 200 papers. Then yesterday he sent me a mail correcting that it is not 200, it is only 100 plus papers only. He said he will correct that. So that shows his humbleness. So he's a very learned scholar. We are very fortunate to have him here and listen to his session. And in fact, personally speaking, I am very fortunate to be here because my elder brothers, they have gone on a pilgrimage, Rameswaram, Kashi, Rameswaram, and I should have been in Kashi today, but I just, because of our faculty recruitment, started with this month, and then MTech second semester examinations, and then MTech fourth semester project evaluation. I had deferred that pilgrimage, and now I am really thinking that it is just God's arrangement that I should be here to welcome Professor Ramasubramanian sir to our NIT community and also listen to his lecture. And with this, I once again welcome all of you to this lecture, and I also thank Ramasubramanian sir for readily accepting to share his contributions with us. Thank you. Then I now request our director to preside over the function and give presidential address. I now request our director. Just one or two remarks.
Respected Professor Ramasubramanian from IIT Bombay, my dear colleagues, as Professor Sridharan has mentioned, this is the first offline activity of the Center for Indian Knowledge System, and we are extremely grateful that we begin this activity, the first offline activity, with none other than Professor Ramasubramanian. And that too, he has researched into the contribution of this state to the world of mathematics. So we can all be proud of that lineage, the heritage of this part of the country. We are all eagerly waiting to hear him, but I just want to when we go through these sutras, everything is in the form of a sutra, so that we can always remember. In the Indian entire thing, we don't believe in that, likhidam, that is all written and then you publish, get patent, all that is, we didn't believe in that. Everything is the oral tradition, even the Vedas and everything. That which has descended in a higher state of consciousness is just revealed to the Shishyas as and when the Shishya is acceptable, deserving. The knowledge is imparted by the Guru in that Guru Shishya Parambara. So if you look at the way mathematics has been, sometimes today when you look at our students and even the teachers, many of us are having a kind of phobia on mathematics. If somebody asks after say 20 years or something, don't ask me all these equations or some theorems and all, we think it is very difficult. And many of the students in the first year, they find it very difficult to cope up with the engineering mathematics. And I feel it is primarily because the way it is, with all my respect to the mathematics teachers, it is because of the way it is taught, and some sort of phobia is created right from the childhood. The mathematics is something like climbing Everest or something. Whereas if you look at the way our ancient acharyas have nicely it is integrated in your day-to-day life. When I cook, when I sing, everything is beautifully. There is that melody and then music. And that is the way mathematics get percolated into the day-to-day life of in this Gurukula Sampradayam. Unfortunately, we lost that tradition, and now we are into a structured, mathematics means some start with this hypothesis, the theorem, axioms, highly abstract, and we lose what is that for me in my life? Even a mom, when she cooks sambar, when she puts the ingredients for a particular objective, we are solving maybe a linear programming problem. So but that is the way our tradition has taught mathematics. Therefore, there were geniuses, great mathematicians in this part of that which is below this Indus River, the great Bharata Varsham. And Bharata is the correct name for this place. Not even because Bharata, that word has some meaning. If you really know, Bhasuram, Bhaskara, Bharatam. That which gives enlightenment, the light, that is this place. Everybody has to come to India for, it is the Moksha Bhumi, Karma Bhumi. That is what the great sages have told. First of all, proof. Can you show that? So that is where I am really happy that Professor Ramasubramanian has done this kind of, rediscovering the past glory of this Arsha Bharata, and then let the youngsters understand we have all this, and we have to reuse that, and how we can do this in our day-to-day life with lot of joy, and then ultimately the purpose is to reach the ultimate. All these are the things in between, but ultimately all of them aimed at that. And I am sure it will be a great session. I may have to leave at 5:25 because of another meeting with our US alumni, but I wish a great interactions, and let us listen to Sir without much time. Thank you, Sir, once again for accepting our invitation. And I also want Professor Ramasubramanian's help, because I don't want students to just understand like a theory and do some lectures in this Introduction to Indian Knowledge System, which is the first course of global elective we are offering. They should undertake projects. They should take internship. They should go to the places and they should meditate and find out what exactly. If you meditate really, you can connect to that past and then find out. And I want Professor Ramasubramanian to help us give the problems to the students, and they will take it as mini projects as part of this coursework. Thank you.
Okay, that is fine. So, namaste to all of you who have assembled here, and I thank both the director and Professor Sridharan for the kind words that they have showered upon. This introduction carried an interesting message. Professor Sridharan was mentioning that today we have a lot of math phobia among the children, and it could be traced back to how things are taught. In fact, this is extremely important message which I have learned. I also got trained like all of you. I had absolutely zero knowledge about the Indian contribution. But there was an opportunity for me to jump, leaving out this modern science, and get into. So I was working in one of the glamorous topics which is called chaos, nonlinear dynamics and chaos. But then there was as he was mentioning, so Daivat, this is what they call. So by providence something happens, and there was an opportunity for me to delve deep into some of the contributions which have been made by Indians, and many of these works are primarily in Sanskrit. And I learnt quite a bit, and I really felt that this has to be transmitted. And definitely I will tell you, the mode in which things are being communicated makes a lot of difference in either cherishing the subject or developing a certain aversion towards the subject. So here there are several means, and you may find several lectures in the web also. Today, my primary aim is to communicate to you a couple of fundamental discoveries, really remarkable, outstanding discoveries which have been made by the Kerala mathematicians. That was the idea. Can we move further? It has to move like this. It doesn't go screen by screen. Okay. So we would have heard all these names. So you may know about this Pythagoras. You may know about Euclid. You may know about Archimedes, Ptolemy. Have all of you heard this? Pythagoras, definitely, right? So yes, the theorem named after Pythagoras, meaningful is the question. Suppose when you want to say Newton's laws of motion, the laws of motion have not been given by anybody, and he is the founder who came for the first time with this, and therefore we want to attribute. If you look at some of the history books, some careful writers, they will not even write Pythagoras theorem, they will write Pythagorean theorem. The distinction is, we don't even know whether Pythagoras made a contribution at all in presenting this theorem. Therefore, they use the word Pythagorean, which means those who belong to the school of Pythagoras. We don't know who the person is. Anyway, the point is, so he was born 570 BCE. Before that, almost 300 years before, we have certain texts, certain class of texts which are called Shulba Sutras. So in Bodhayana Shulba Sutra, we have this theorem. So Dirgha Chaturashrasya Akshnaya Rajjuhu Parshvamani Tiryangmani Che Yet Prithak Bhute Kurutaha Tadubhayam Karoti. This is how the sutra goes. And therefore, we should know that this most fundamental theorem in geometry is something which has been known to Indians at least centuries before. This is the most fundamental theorem in geometry, let me tell you. It is not something which has to be undermined even when some of the people who took interview. So we were just seeing that there is a plenty of application for this. Okay, so that is one thing. Then Euclid, we know Archimedes, I am not going to delve into. Then Ptolemy, who made a very, very important contribution regarding, these are some of the most important Greek astronomers and mathematicians. Okay, next. Then you see, I am just jumping from 2nd century, okay, Common Era, to almost 16th century Common Era. So in between, almost for 1200 years, it was a dark age in the West. In fact, historians call it as a dark age because nothing much came out in the West. So only after 14th, 15th centuries, we have some sort of a renaissance which is happening in the West. But it is during this period where Indians have made immense contributions to the advancement in mathematics and various other disciplines. So we know of Descartes. So the Cartesian coordinates that we have is all sort of introduced by him. Then we have Pascal. So anybody who knows about Pascal's contribution? Have you heard of something, students? Huh? Pascal's triangle, right? So this Pascal's triangle essentially gives you the binomial coefficients, right? But these binomial coefficients are actually found in the work of Pingala. Have you heard of Pingala? Pingala has written what is known as Chandas Shastram. He was referring to 6 Vedangas. One of them is Chandas. Chandas essentially means basically the metrical form, recognizing the metrical form. So this Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwaraha. This Sabyasachi was quoting this verse, right? You see, there are 8 syllables per quarter. So this is one kind of a metrical form. There can be 6 syllables, there can be 26 syllables per quarter. So all of them are forming a part of the study of Chandas Shastra. In fact, each of the syllable, suppose we take the name Shri Dharaha. How many syllables are there? Shri Dharaha. So Shyama Sundar, your registrar. Shyama Sundara. There are 5 syllables, right? Shyama Sundara. So of them, Shri is a long syllable, Dha is a short syllable, Raha is a long syllable because you have a Visarga. So Guru, Laghu, Guru. Shya is a long syllable, Ma is a short syllable, Sun is a conjunct consonant, long syllable, Da is a short syllable, Raha is a short. Guru, Laghu, Guru, Laghu, Guru. So we have this kind of recognition of pattern. In fact, this is something which is extremely important even for music. So whether it is poetry or music, this pattern recognition, of course, this is very important even in your face recognition. So today all this data science is all oriented towards, if you just show the image, it will get you the name of the person, so where he is and so on. This is all basically data recognition and pattern recognition. So anyway, this pattern recognition started long back for studying the structure of the Veda itself, and there you find this Pascal's triangle, binomial coefficients appearing. Okay, that is a different topic. We just know. So that is not true. Then Bernoulli, we know Euler, of course, a famous mathematician. Next, please. So this is the world of mathematics. 2 major figures whom I wanted to highlight was as a special thing. So most of us do a course on calculus. See, at least some introduction to calculus will be there in +2 and little more there in the engineering, of course. So 2 major figures are Isaac Newton and Leibniz. So these are the names that we find. So they belong to the 17th century, as you can see, 1462, 14. So they were more or less contemporary, and they were actually trying to fight with each other also for certain things. Anyway, that was happening. So these major figures owe their origin to something else in the much early period, so Archimedes and so on. But the major contribution which they have done is to the area of what is known as calculus today. So what is calculus? I will just tell you. Next, please. And how. So the text which he was mentioning, Ganita Yukti Bhasha, is a Malayalam text. So many of you should know. There is one important text, very important text, which has been authored in a local language, is called Ganita Yukti Bhasha. Okay. So the word Yukti Bhasha itself comes from, Yukti is rational, Bhasha is something which is spoken. Bhasha is Bhashyate iti Bhasha. So Yuktayaha Bhashayam means the rationales have been presented in the local language. So that is how one can understand the title of the text itself. Okay. So now this calculus is basically a language in which we find the rate of change of motion. This rate of change of motion is something which is extremely important in all disciplines. So even when you want to, as he was saying, so Supa Shastra is basically chef's work. Okay, the work which is done. Suppose you want to take laddu. So the consistency of this sugar syrup, if it goes beyond, it will become powdery. If it is less, nothing will get bound, right? So everywhere we have calculation. So whether it is Supa Shastra, whether it is Kama Shastra, whether it is Vyakarana Shastra, so mathematics is all pervading. In fact, there is a beautiful verse which says, Trailokye sacharachare yatkinchidvastu tatsarvam ganitena vinanahi. Understand? So he starts with saying, so Vaidike laukike vaidike vapi tatha samayike piyaha vyaparaha tatra sarvatra sankhyanam upayujyate. Okay? Whatever be the kind of operation that you can tell me, So it all involves mathematics at some level. Okay? Even when you want to chase a girl, you have to do some calculation, right? So wherever it is, I mean, calculation is something which has to be done. Okay. Anyway, so this calculation has to do with the rate of change of motion, even when you want to say Tithi, Nakshatra, Ekadashi, Dwadashi, Navami, Krishnashtami. Okay. Whatever it is basically calculation of the separation between the sun and the moon. So these are all things which drive mathematicians and astronomers to come up with theory with which they can make this prediction. So this is something which has been, so the reason for quoting this is Ganita Yukti Bhasha has been referred to by well-known mathematicians as the first textbook on calculus. So this we should know. So this is much before Newton and Leibniz came into this earth. Okay, so there is fantastic thing which is there. I will give you a glimpse of that. Okay, so this is something. By the way, if any of you would need some clarification, you can feel free. You can raise your hand. I'll be very happy to answer. Okay, if something is not clear. Okay, next. While entering here, I saw this the hall named as Arya Bhatta. It is wrong. We should not have two T's. We should have only one T. Arya Bhatta. Okay. So Bhatta is something which we see. So this text itself has a verse. Okay. Arya Bhattastvih nigadati kusumapure bhyarchitam jnanam. Which means Arya Bhatta here presents. Here means in this text. At the beginning of the text he says. The verse itself, Arya Bhattastvih nigadati. So it cannot have Bhatta. Bhatta means there will be a problem in the metrical composition. Metrical restraints will be violated. Okay, and therefore we should have only Arya Bhatta. In many places this error is there. I thought I'll just tell you. So Arya Bhatta, so you see in the in the last line of the table, we have Arya Bhatta. He is in 499. He gives a value which is correct to 4 decimal places. Okay. So the verse, this value 62832 by 20,000 is presented in a verse. Okay. Chaturadhikam shatam ashtagunam dvashashtistatha sahasranam. Dvashashtihi sahasranam means 62,000. Dvashashti is 62, sahasra is 1,000. Dvashashtistatha sahasranam. So 62,000 plus Chaturadhikam shatam, 100 plus 4. Chaturadhikam shatam, ashtagunam. What will be that? 832. So 62,000 plus 832. If that happens to be the circumference and the diameter happens to be 20,000, you will get the value of pi. That is how he gives. It is a ratio. So if 20,000 is the diameter, then 62,832 will be the circumference. So the ratio of that will give you the value of pi. This is how Arya Bhatta presents, which is correct to 4 decimal places, accurate. Another flaw that we find in the text is something which I thought I should just bring it to you. So those who are interested in studying history of mathematics, you may not be interested today, but later definitely you will become interested in life. So you should know that. So here you see, after Arya Bhatta, when people present the history, they will just jump to 1600 as if nothing was there. I'll just give you a slide which will tell you. Is this omission in the book which deal with history of mathematics out of ignorance, or is it due to some other factor? So this, when we probe into, we see that it is not necessarily due to ignorance. I'll just give you an illustration. Next, please. So here is a snapshot of a page of a book which primarily is meant for introducing the history, the idea of history in the development of mathematics to a common reader, teacher, etc. This is authored by Alex Bellow. See, as you can see. So this Alex Bello once came to my department. So he wanted to take an interview with me. He is a sort of writer. So he just talked to me, and then at the end of the conversation, he asked me, it has become fashionable for people to say that calculus was invented in India. What is your take on that? This is the question that he poses to me. Right? I will repeat. It has become fashionable to say, for people to say that calculus was invented in India. What is your take? I said there is nothing fashionable about it. It is a fact. That is what I said. But then, before leaving, the interview was over on a different topic, and then he left, gave me a book. And after a few weeks, I just flipped through the book. And I was stunned to see this person writing this. You see, what does he say? For 2000 years, the only way to pinpoint pi was by using polygons. Okay, the value of pi. Okay, it is a very, very mysterious number. It's a beautiful history in itself. But in the 17th century, you see, the first sentence he says, for 2000 years, which means, he is talking about the Greek mathematicians who were dabbling with the value of pi. Okay, the time of Archimedes and so on. Okay, it is 3rd century BCE. And then he moves to 1600. 17th century, Gottfried Leibniz and Gregory. In fact, the mathematics teachers will know that the series that you have is called Gregory-Leibniz series. It is called Gregory-Leibniz because both of them sort of found more or less at the same time they were fighting with each other who should be the founder of this series and so on. So this pi by 4, this series, is something which has been given by Madhava 3 centuries before. So he is writing this book. He is asking me the question whether calculus was invented in India, but he completely hides the contribution of Madhava. He only projects Gregory and Leibniz. So how is it intellectual honesty? See, so that is what I wanted to tell you, that a history which has been authored by various people, partially due to ignorance, partially due to certain other considerations, does not necessarily reveal the actual history. Okay? So this is the message that you have to keep in mind. This is particularly important for you because this discovery is something which is outstanding discovery in mathematics. Just look at this series for a minute. So you don't need to do great mathematics, okay? Those who have not trained themselves in mathematics, just look at this. All of us are familiar with numbers. So what you find in this series is just odd numbers appearing. 1, 3, 5, 9, etc. in the denominator. And there is an alternating plus minus sign. And this is a never-ending series. Never-ending means, it just goes on up to infinity. Whatever value that you will get is equal to pi by 4. So this is something which is a fantastic series in itself. So you represent some finite quantity in terms of infinite series. This is one interesting thing. The second interesting thing is, it is an alternating series with plus minus sign which goes on. The third thing is all the odd numbers appear and then you divide by, you take unity and you will get something which is physical in nature, circumference to diameter ratio. This is something, how did they come up with this? Next slide. When I saw this series given in the form of verse, I was quite excited. I also know only as Gregory-Leibniz series. But then it is beautifully presented in the form of a verse. How many of you cannot read this? All of you are familiar with Devanagari, right? Hindi script. Okay. Vyase varidhi nihate Rupahrite Vyasasagarabhihate Trisharadi Vishama Sankhya Bhaktam Rinam Swam Prithak Kramat Kuryat. This is how the series is presented in the form of a verse. Vyasa in Sanskrit means diameter. Vyase Varidhi Nihate. Varidhi means ocean. In Bhuta Sankhya, it refers to number 4. Okay? Vyase Varidhi Nihate. So when the diameter is multiplied by 4, and then he says Rupa Hrita. Rupa refers to 1. This is what is known as Bhuta Sankhya. Bhuta Sankhya is you refer to some number by referring to an element in nature. This is object numerals. Suppose I say Netra. What number comes to your mind? 2. Suppose I say Veda. 4. Suppose I say Ritu. 6. Say Shad Ritu. Okay? So this is how the Bhuta Sankhya goes. Okay? So here he says, suppose I say moon. There is only one moon, right? Similarly, Rupa means form. The form of every individual is unique. Any object in that, for that matter. You take 2 identical balls, even then they will be unique at some level. So this Rupa is 1. Rupa Hrite means divided by 1. Then Trisharadi, the first number is divided by 1. The successive numbers, numerals 1, are going to be divided by 3, 5, etc. 3 is 3. Shara means 5. What does Shara mean literally? Shara, arrow, bana. Why does it refer to 5? Huh? Panchabana, somebody said. You said? Panchabana. Who is Panchabana? Panchabana means 5 arrows, right? In fact, when I entered this, studying this discipline, I also did not understand. I understood Veda means 4 and I understood certain other things. Netra is 2, Akasha is 0 and so on. But Shara, Bana they use for number 5. So then I asked my father. So I asked him, why is this Shara referring to 5? So he said it refers to Manmatha. He is called Panchabana, therefore 5. Then I asked him why that is called. Then my father said, so if Manmatha shoots arrow, then all your 5 senses will be gone. You understand? So Manmatha's arrow will make us lose all our senses. So that is how this he said this is called Panchabana. Anyway, so Trisharadi Vishama Sankhya Bhaktam Rinam Swam. Rinam is subtraction. Swam is addition. Prithak Kramat Kuryat means you keep doing it sequentially. Okay? So this is how the series is beautifully presented. This is not an easy thing. How does he get this? I wanted to just give you a flavor of that. You don't need to really worry about the details, but as your director was also mentioning, so it is not something which they came up with like a trick or a magic. Okay? So certain intuition will be there, but this intuition, Devata Prasada, which we try to get by acquiring a tranquility of the mind. What we need to understand is there is a physics behind it. There is a chemistry behind it. Ultimately, whatever we want to do, we need a certain tranquility in the mind. And the tranquility in the mind brings in a certain clarity in our thinking. In fact, even Nilakantha Somyaji, so who is the son of this part of this Kerala, okay? So who is actually in the lineage of Madhava, which I will just show you. So he asked this question once. Devata Prasada. So when we say Devata Prasada, what does it mean? He says, see, Devata Prasada does not mean Brahma or Aditya is going to come in front of you and then reveal you something. Okay? Natu Brahma Adityo va Swayam Agatya Upadishet. What does it actually mean? It means Mati Vaimalya Hetuhu, a certain practice which has been tested over time. So this is to be understood. Okay? So this is something which is a profound thought. I just inject it into your mind. So you should just think about it. Okay? So these are all people who have been regularly practicing certain things. I mean, they are trying to explain this to us in simple language. Next, please. So in fact, the mathematics head of the department was asking, we have 3 halls, we want some names to be given to those halls. So trying to highlight the contributions which have been made by mathematicians of this part of the world. So we did not know even about Madhava. Madhava is a tall figure. He is the founder of the Kerala School of Mathematics as we know today. Madhava, then we have Parameshwara, then I was talking about Nilakantha Somyaji, then we have this Jeshtadeva. The Yukti Bhasha, which I was just referring to, a Malayalam work, is by Jeshtadeva. Okay, that work is today boldly proclaimed as the first textbook on calculus. Okay, so this is something which you need to know. Then we have Shankara Varyar, then we have Pudumana Somyaji, then we have Achyuta Pisharadi. This is just to give you a glimpse of the important Kerala mathematicians and astronomers. Okay, so important Kerala mathematicians. Many of you would be knowing this Narayanium, right? You have heard. Who is the author of that? Melpattur Narayana Bhattathiri. So Melpattur Narayana Bhattathiri studied under Achyuta Pisharadi. I don't know whether you know that. This Achyuta Pisharadi who comes. So Achyuta Pisharadi is the teacher of grammar for Melpattur Narayana Bhattathiri. The Achyuta Pisharadi teaches grammar to Bhattathiri. Bhattathiri's Narayanam is an amazing work. Anybody who has some understanding of Sanskrit, okay, some introduction to Sanskrit, will be amazed to see the kind of work that he has created. It is nothing but a work which has come out of a divine blessing. I mean, nobody will be able to write like that. It is just like our Kalidasa, understand? So it is just certain things are inspired and then you come up with something. So it is like Ramanujam as he was quoting. So it is a certain inspiration, that is what we call as divine grace. Okay, that comes. So this Achyuta Pisharadi teaches Narayana Bhattathiri grammar, but he himself is an astronomer. In his work, we find some very, very interesting mathematical equation. You teach, so how to find the derivative of ratio of two functions, right? What is it called? So we memorize it as the denominator. Then numerator, then minus numerator, derivative of denominator, all that we do. Okay? And this is for general function, g of x by f of x. So suppose we have a trigonometric function, okay, both in the numerator and the denominator, and we have to find the derivative of it. So that is given by Achyuta Pisharadi. It is an amazing thing. Okay? How did they get this exactly? I don't know. But it is exact result. That is something which I wanted to tell you. So these are some fundamental contributions which have been made almost centuries before. Okay, this is just you see 1550. So Newton is born around only 1640, and this is a tradition which has been going on. Okay, next please. So this is a very important thing that you should know. The sine function. So I was asking some of you, so how do you explain? We explain it as so opposite side by hypotenuse. This is how we generally teach. But when we do little higher mathematics, this sine function is basically represented as an infinite series. Okay? So x minus x cube by 3 factorial plus x to the power of 5 factorial. See, so minus x to the power 7 by 7 factorial and so on. This is again an infinite series. So this series is again given in the form of a verse, like just I was quoting, no? Vyase varidhinihate. Similarly, there is a verse which is given in the text, which gives this sine series. So this is simply not possible unless you have understood the fundamental principles behind what we call as calculus today. See, so this is something which is going to be conveyed to you in the next 10-15 minutes. Okay, so you have to just follow. You see, the beauty is something which one has to first of all know. So of course, any engineering student, I mean, you should be knowing this. So this, you look at the equation 3 here. In the left hand side, you have a sine function, and then d by dt is rate of change. D by dt essentially means the rate of change of that function. So the rate of change, so suppose the sun moves. Do you know what is a tithi? Huh? Tithi, arayo. Date. Krishna Janmashtami parayo. Krishna Janmashtami. How do you call? Janmashtami, right? You have Rama Navami, Ashtami Rohini. So what is this Ashtami? Ashtami means 8th day. So you all of us have seen this Purnima, right? We have seen this Amavasya, right? So these are things which we... So you call Purnima as Purnima, right? In Malayalam. Paurnami. Amavasya. Huh? Okay. So this Amavasya is essentially the sun and the moon in the same line. Correct? Moon does not have any light. Moon only reflects the sunlight. Correct? Moon basically reflects the sunlight. So as moon is moving around the earth, so sun is the light emitting body. So you see, when the moon is in line with the sun, half of the moon will anyway be illuminated all the time. So when you have a ball and a source of light, half of it will always be illuminated. But this fellow, so suppose this is sun, so moon is coming in between. So that half will be bright. This half which I am seeing is dark. This is what you call as Samavasya. But when it comes in this opposite direction, so you see the full half of the moon. This is what we call as Paurnami. Right? Now, from Amavasya to once again Amavasya, in between Paurnami will be there. So this you call as a month. Okay, lunar month. 1 month. And this month is divided into 30 tithis. 30 tithis. This time period. So moon starts here, it goes round there, comes back to the sun. It is a time period. It is like some fellow going around the ground. So he will just go 1 round, come back to the same starting point. He has completed 1 round. This 1 round period is what is called as lunar month. This is divided into 30 parts. 30 tithis. So when you divide that, so how much, so when the moon is moving, the sun is also moving as seen from the earth. But anyway, the lead of the moon over the sun will be 360. Suppose sun has moved theta degrees, the moon would have moved 360 plus theta. So theta you leave, so lead is 360. That 360 you divide by 30, you will get 12. The time taken by the moon to lead the sun by 12 degrees is what you call as a tithi. Okay? Tithi essentially means the time duration taken by the moon to lead the sun by 12 degrees. And this will not be uniform. Will not be uniform because they are moving at variable speeds. That is where this mathematics comes in, the calculus. The calculus aspect, rate of change. Okay? So Kepler's law rayo, Kepler's law. Padichu? Illa. Adi endha change? Kepler's law. First law. Huh? All the planets move in elliptical orbits, right? இரண்டாமத்து law? The area traced by the planet, okay, will be constant, correct? The radius vector traces an area. That will be constant. Okay, so this is what the second law is. So there you find the rate of change. The reason for asking this question is, wherever you do, even when you want to drive a car, so suppose from here you go to Trivandrum, okay, which is too far a place. So I went to Payyanur, let us say, 150 kilometers. So this Payyanur, from here, I took almost 3 hours, let us say. So what will be the average speed? 50. But in between you have variation, right? All kinds of variations. So the rate of change, so is what we call as, so how far can you move in a short period? So this is what decides. This vehicle can accelerate so fast, all that we say. So this rate of change of motion is something which is extremely important. The rate of change of population. Okay. So everywhere the rate of decay of a concrete building, whatever you want to consider. Okay. So all of them have to do with the study of the rate of change. It can be in discrete part, it can be in continuous part. So here we are, even with the calculation of a tithi, which has been there for ages in the Indian tradition, it is essentially the rate of change of the moon's motion. See, it separates from the sun. At what rate it separates? The duration of a tithi can be almost 23 hours. It can be 25 hours also. Okay, for covering this 12 degree, it can be widely varying. But you have to capture them in mathematics. It is in this context you find this d by dt appearing. Okay, I am trying to give you. Enda question undo, prashna undo. La. So this d by dt is basically the rate of change. Okay, you have a function, the right hand side. Forget about all that. Okay, details. So there is a sine function. You want to find out the rate of change. So there they give you this expression in the right hand side. So that is exact derivative. Okay. So that is what I wanted to tell you. Okay. So this is something which is remarkable, and this is attributed to someone called Damodara. This Damodara was the son of Vatasheri Parameshwara. So Parameshwara's son is Damodara, and Parameshwara is the disciple of Madhava. So this is quoted by Nilakantha in one of the verses. See, this whole expression in the right hand side is again written in the form of a verse. Chandrabahu phalavarga shodhita trijyaka kritipadena samharet tatra koti phalaliptika hatam kendra bhuktirihayaccha labhyate. That is how the verse goes. The moment I saw, I was quite thrilled. I mean, I'm talking about 30 years before. So first time when I read, I was astonished at how come this relation has been arrived at when there was no notion of rate of change, no notion of calculus and so on. So this is how they have codified these very important results. Next please. These are signal achievements of mathematicians. So how many of you are familiar with this? This kind of triangle doing geometry? Yes, no? So of course, I am not asking, these are also mathematics teachers. Okay. So what part of this group is doing science, engineering? Just lift. Almost all. Okay, then you should just follow this. This is, I wanted to just convey to you, don't get into the details of all this working out, but I want to appreciate how small things can lead to phenomenal result. That is the idea. The fundamental principle which is involved in arriving at the infinite series, which I showed you, has to do with simply comparing. One, you should know this so-called Pythagorean theorem, Shulva Sutra. The other is, you should be able to identify the similar triangles. That is all. Nothing more than that. That is the principle which is involved. Okay? So, analyzing a geometrical figure, okay, the conception, that is why it is very important to trace the idea. It is not the result which is important, it is the idea behind arriving at this result which is important. Okay? So, that is what is creativity, productivity and so on. You look at this, so here this is 1/4 of a circle. You see, what you see here, this is 1/4 of a circle. Around 1/4 of a circle, you take a square, draw a square. And then you divide that, the top portion into n parts. See, P0, P1, P2 and so on up to n. N equals segments. You take a line, divide that into n equal parts. Okay? Then you draw a line from the center to those points. Okay? OP0 will be equal to R. What is OPN? Quick. Suppose I say OP0 is equal to R. What is OPN? Root 2 times R. Right? So this will be R, that will be root 2 times. All other things will somewhere fall in between. Right? So you have divided into n equal parts. Now you consider some nth rth part. See, I am writing it as PR minus 1. Okay? R is less than n, some number. So you see that there is a similar triangle OPR minus 1 AR, right? PR AR is perpendicular to the line. OPR minus 1 AR, OAR minus 1 B. These two are similar triangles, right? So you get one relation with that. Then you conceive of that triangle PR minus 1 PR AR. See, this is the small thing. So this is one triangle and there is one more similar triangle you will get. So you just find the ratios of this. Why are we doing this? So this, if you understand, that is good enough. We can just throw away a few slides and go to the last slide. See, there are two similar triangles which have been identified. What is my purpose? The purpose is to find the relation between circumference and diameter. Pi is that, correct? So my idea is basically to find out the circumference. Circumference is P0, AR minus 1, AI and S. This will be 1/4 of the circumference. 4 times that will give you the perimeter of the circle, right? So this is the idea. I want to find out the perimeter of the circle, the connection. So the perimeter and the diameter are connected by the value pi. So I want to get the expression for pi. That is my problem. So they have posed the problem like this. Very simple. Nice description will be there. So you consider these triangles. So now my idea is the following. I will find an expression for AR minus 1B. See, that small segment. So by similar triangles, I will try to find out that length of the small segment, AR minus 1B. Okay? Once I get this, when I say that this is going to become smaller and smaller and smaller, what will happen to that segment? AR minus 1B, as you keep reducing the gap, it will almost become the circle, right? You understand? So initially I get the segment value. But if you make it small, 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 that will more or less become the circle itself. So I make a summation, I will get the result. This is the principle. Okay? Just go to the next slide. Yeah. So the text will say, Paridhikandasya ardhajya paridhyamsha eva. Paridhi means circumference. Ardhajya means that segment. That segment will almost become the same as the circle. Okay? This is how the argument. So this is how in the limit this goes to this today. This is what we describe in the classes. Okay? In the limit n tending to infinity, this becomes this. So it is essentially the same argument that you find here. That is why we say that this text should be considered as the fundamental text on calculus, the first text. Next book. Yeah, just go, leave it. So I am just going to, so this is all basically some summation. Next. Just to show here. You see, ultimately, suppose I integrate x square. What is the value? X cube by 3. X to the power of n, n plus 1 by n plus 1. Why? So it is something which has to be memorized, or? In fact, this comes out beautifully. So you see, this is all done in discrete. So you think of I is some number, let us say. Okay? You know 1 plus 2 plus 3 up to n, what is the value? N into n plus 1 by 2. Right? Suppose n is large. How can you write it as? I am writing 1 plus 2 plus 3 up to n is equal to n into n plus 1 by 2. How will I approximate? Suppose n is large. Right hand side. N square by 2, right? You can neglect when n is too large, so n can be left out in term compared to n square, correct? So the right hand side will be n square by 2, right? Now, the same principle is employed here. I am in the left hand side, I is equal to 1 to n. 1 plus 2 plus 3 to the power of k. So I am just calling you. So 1 plus 2 plus 3. Suppose you take 1 square plus 2 square plus 3 square. So it will be n cube by 3. So 1 to the power 4 plus 2 to the power 4 plus 3 to the power 4. So 1 cube plus 2 cube plus 3 cube, what is the? You should have studied, no? What is that? 1 cube plus 2 cube plus 3 cube plus and so on n cube. N into n plus 1 by 2, the whole square. So when n is large, n to the power 5 by 4. You understand? So that is what I have written here. So you make summation I to the k. The k can be 1, 2, 3, whatever. Okay, I runs 1 square plus 2 square plus 3 square, 1 to the power 3 plus 2 to the power 3 plus 3 to the power 3 plus n to the power 3. All of them is n to the k plus 1 by k plus 1. That's all. Okay. So this is a fundamental result which they have arrived at. Okay. So this has to do with the notion of the limits. So this result is what gives you the infinite series. So that is all I wanted to convey. This is a very, very important thing. And the way that it has been arrived at is something which is astounding. The way it has been arrived by the Westerners, Leibniz and Gregory, is totally different. So here it is a simple thing. So there are only 3 things. One is this Pythagorean theorem, which is known from 3,000 years before. The second is similarity of the triangles. And the third is the summation of powers of integers. Summation of the powers of integers. Normally we study in our schools, see 1 plus 2 plus 3 up to n, first order summation, n into n plus 1 by 2. Okay? Second order summation, n into n plus 2n plus 1 by. So this is how we do. And this we do like this. So So this is how you have the series, and this is the verse. Trisharadi Vishama Sankhya Bhaktam Rinam Swam Prathakramat Kuryat. Okay, next. Wait, just before we go, this series, I don't know how many of you have studied this Convergence of Series. You have a chapter called Convergence of Series. Is this series a fast convergent or slow convergent? Any idea? This is a terribly slowly converging series. Okay? So, see this, what you have to understand is, this plus minus always means there is a value here. You jump here, you jump there, you jump here, you jump there, you jump here, you jump there. If you can quickly come to the value, then it is called fast convergent. But if you have to keep on doing, okay? So here, for even getting 4 decimal place correct, using this series, you have to use 1,000,000 terms. How will anybody do? Just imagine, in those days, no calculator, no computer, nothing. Suppose you have 1 minus 1 by 3, plus 1 by 5, minus 1 by 7. You have to calculate every term and then keep on adding, subtracting. Where will you end up? You understand? One is the beauty of the series. The series may be beautiful. It is like somebody saying, the person is very beautiful, but dimag mein kuch nahi hai. So, what is the point? See, Akriti is very nice, but Antaha kimapi nasti. So, what is the use of that person? Right? So, similarly, the series may be beautiful, but this series cannot be used. What is the point in getting this series? So, you create a beautiful house, but it is unlivable. Okay? So, this is something like that. So, this, for handling this issue, they have come up with a brilliant technique. Okay? Convert this into fast convergent series. All this is done by Kerala mathematicians. That is why I am just bringing in. You should know. See, immense contribution that they have done. So, the one is calculus aspect. The other is analysis aspect. These are all called as analysis in mathematics. Next. So, the series is an excruciatingly slowly converging series. To obtain the value of pi correct to 4, 5 decimal places, we consider 1,000,000 terms in this. Okay? And they use a technique. In fact, there was one of the panelists in the interview. He will always call, what is the technique? Technique. Okay? So, they used a technique which is called as Antya Samskara. You know Antya Samskara? Eppo cheyyana? Iddeham poya pinne, right? So that is what is called Antya Samskara. So this Antya Samskara, they do something. So they take the last term and do something, and they call it as Antya Samskara. You don't need to do anything further. That is what it essentially means. So okay, this will take care of the accuracy. Next please. And just by using 20 terms, you can arrive at 8 to 9 decimal place value correct. This is amazing technique. Next. I am not just going to discuss all this. Just leave that. Leave. Further. Just go ahead. Just move ahead. So this is what we today can call it as error minimization technique. Okay. Today we can call it as, that is the kind of thing that they have been done, and this graph tells you, see, this is the number of terms that have been considered in the series. And accuracy, you see, the y-axis you find 10 to the minus 1, minus 2, minus 3, minus 11. If you just consider around 50 terms in the series, you can get almost 11 decimal place accuracy. So that is the kind of a thing that has been achieved by this. This is a fantastic discovery that has been made. And there is a lot of analysis which goes on to arrive at this. Okay. Next. What is there? Can you read Malayalam? Anybody? They're too difficult, no? So in fact, I was struggling reading manuscript in Malayalam. Okay. This is 15, 20 years before. Okay. This was really, see, that has been written as, see, Samapanchahatayaha Ya Rupa Diyujaha Chaturghana Mula Yutaha Tabhishodasha Gunitat. So that is what is there basically. You will find these notations. See, there is a Chandra Bindu, there is one line. These are all basically Guru Laghu. You see, Sa, Ma, Pan, Cha. Cha is a long one. Therefore, he puts a bar. Sa, Ma is too short. Lagu, Lagu. Pan, Cha, Guru, Guru. So that is what is basically marked there. Okay. So in the lines, Samapancha Hatayaha Ya Rupadyaha, this is the series that is given. See, in the denominator now, earlier you saw 1, 3, 5, correct? Now what do you find? 1 to the power 5, 3 to the power 5, 5 to the power 5, 7 to the power 5. So obviously it will be fast convergent. So then it was terribly slowly convergent. You transform the series into some other form. See? So when the denominator increases, so it will very fast convergence. So that is why we have sine series, 7 factorial, 10 factorial. Just consider 3 terms, 5 terms, over. See, that is how we have to understand this. So this is again put in the form of a verse. So this transformed Madhava series. Okay. So this is something which is a brilliant contribution. Next, please. Just next, leave. So this is how some of the Sanskrit manuscripts will be there, okay, just to show you. So how people have preserved this. Today we have all sorts of devices, computer, iPad, this, that. So iPhone, various things are there. But then only way is to either store it here or with great difficulty put it in the form of manuscripts, okay. Next. So you see they are very, very tightly written. See, this will be just 4 inches, 5 inches, so that's all maximum. So they will be very tightly writing, very difficult in those days. Next. So this is a manuscript which gives you the equations. Wherever you find that line, so they don't write equation x square by 3 minus y cube by 4. They will put it in the form of text itself. So there this bhu 2 means 2 square, bha va varga, va means square. So va, so we have to understand all this. So initially, so this is just to give you a glimpse of how the knowledge has been sort of preserved. Next. You see, this is all the more difficult. So Devanagari to some extent, this Malayalam thing, see, it is all palm leaf written. See, if you go to Trivandrum, they have a huge, here also somewhere people may be preserving. Everything is written in the palm leaf. So palm leaf with a steel, okay, they will write. So they will engrave in that. So that engraving has been done and they have to conserve space. Today when I find people, sometimes I wonder, these people just scribble some 4 lines in a A4 sheet and then they dispose. See, for this will be a palm leaf which is hardly 2 inches wide and it will be some 10 inches long. So they would have written almost 10 pages in that. So tiny. So that is how they have to sort of preserve. So this is just to tell you how this knowledge has got transmitted over generations. And so fortunately we have some people who have been preserving this in spite of the onslaughts. So we were able to get some of these things and we are enjoying the kind of rich heritage which has been there here. Okay. And anybody from computer science background here? Okay, even this computer science student, they don't study this Donald Knuth. This Donald, do you use LaTeX? You use LaTeX, right? Have you heard Donald Knuth? This LaTeX is a package, right? Who developed this package? The idea behind is Donald Knuth. He is a Arayo, pair. Ketundo, illa. Okay, sit. So this Donald Knuth is an amazing man who developed a brilliant package called LaTeX, which most of the science students they use. Even engineering they may be using for writing papers, etc. Anyway, it's a fantastic package. That is one aspect. But the other aspect is he has written volumes which is known as the art of computing. Okay, the art of computing. It is a several multi-volume text. And he does, the amount of research that he has done is amazing. Once he posed a question to us, it came through a Fields medalist. He was asking, what is the source of this Sanskrit text? None of us knew. So that kind of a thing. So the reason for quoting this is, see, in one of his talks, he makes this interesting remark, highlighting the fascination that one has in working with the history of science. He says, my major failing as a teacher was I wasn't able to get a single one of my 28 PhD students to realize what a thrill it was to work with the source material. You understand the meaning? So source material is those kinds of manuscripts. And if you go back, how did that material come? Manuscript is just a transcription of the idea. So you go to the source and then try to find the idea which gave this brilliant thing. So he is such a fantastic man. And it is something when we try to look at the manuscript, work very hard. See, I sometimes have worked to one single verse. You may have to break your head for a week. But at the end of it, you will have the thrill. That is what he means. What a thrill it is to work with this. So this is something which is very important for students. This degree and getting mark and getting some salary, 6 lakhs, 16 lakhs, I mean all of them is just, for a few months it may be interesting. Or a few years it may be interesting. But beyond that, nothing is going to be interesting. So if only we try to engage our mind, trying to find something new, debug something, find, this is where the thrill lies. Otherwise it is just like a cow living, this living. Okay, so this is all. Next. Okay, just leave. So this is some history. Next. Okay, so this is a message that I want to give. So there is a beautiful thing, Kalidasa you would have heard. He says, Puranamityeva na sadhu sarvam, na chapi kavyam navamityavadyam, santaha parikshya anyatarad bhajante, mudhaf parapratte neya buddhi. So just because it is old, one should not say it is all great. Just because it is new, one should not just throw. Okay, parikshya anyatarad bhajante means you examine. See, what is good in this? What is this? So this is how we have to. So that is how a wise man leads his life. This is a very important message. Okay. Next. So when he says, Professor Sridharan says, Indian knowledge system, Indian knowledge system. I mean, what one has to understand is, so there are certain aspects in it which bring in pride, which are absolutely useful even today. Okay. There are certain things which we may have to just evolve over a period of time. Okay. So those things are left out. That's what it means. Okay. The final slide is, the study of this ancient text is essentially trying to understand the evolution of ideas. This is what I have been trying to tell you. How did this idea come up? In what context it came? So that is what is important. Okay, for us to understand and appreciate. The simple and intuitive ways in which some of the results have been arrived, that is why I gave you an example. Okay, there are 3 basic principles which are very simple. But it is the application which has given rise to this brilliant infinite series. So that is something which is astonishing. We saw it for pi. There are many other things like this. Even if we find better methods, a thorough understanding of how the ancients have approached this problem provides useful insights. Okay, so this is what we have to understand. If it is not applicable here, it will be applicable elsewhere. That idea has to sink into the mind. We would be doing considerable harm to our children if while framing the mathematics curriculum, we do not pay attention to highlight any of these important things in the impressionable age. So this is the age in which things get completely registered in the mind. Beyond that, it doesn't really work. Okay. See, one thing I'll tell you. I myself try to learn something new today. But what happens is, this thing which gets into my mind just goes out like the water from a leaking pot. You understand? In those days, 30 years before, the moment you read something, it just permanently lodges into your mind. This is what happens with aging. With aging, it is like water in a leaking pot. But when it is in impressionable young age, things get lodged. So it is extremely important for the teachers to drive in the right things in the right manner when the mind is so receptive. So that is why the job of a teacher is just like the job of a sculptor. Okay? Carefully we have to mend this. This is something which is very important for us to understand. Whether we grow our children at our home or we deal with our students in the institution. This is very important. So making unverifiable claims or exaggerated claims is unscientific. But what is scientific about suppressing some information? Okay? So this is what we see in certain things. Next. Thank you.
Any question from the audience? Any doubt, any query?
Namaskaram, sir. How is the concept of zero and infinity developed by our Indian elders? Thank you, sir.
Yeah, this is something which is quite important to understand. After all, this notion of zero and infinity, they go together, as all of us can understand. X by 0 is infinity, right? So anything by 0 is infinity. This is what we say. So they are just two kinds of things. So, but today we will be taught that dividing by 0 is not correct, etc. But anyway, it doesn't matter. So let us set it aside for a moment. But they are tied together, right? So if you have something, and then if you multiply by 0, okay, so it collapses. So 0 is a very mysterious number. In fact, some of you should just read this beautiful book. The book is titled 0, The Biography of a Dangerous Idea. You understand? This is written by Charles Saffe, Charles Siefe. So it's a very interesting book. So this idea of 0 was itself perplexing for a long time. So initially people dealt with only numbers starting with 1. So then that is why it is called natural number. Then when you include 0, you call it whole number. Then you go to the negative side, you call it integer. And then it goes on increasing, you call it complex numbers today. Now the idea of 0 was not at all received in the other civilizations. Whereas in our civilization, it was something which is integrated with the philosophy. Okay, we have the notion of abhava, we have the notion of shunya. In fact, even in Pingala's Chanda Shastra, which I was just quoting, 3rd century BCE, we have the word shunya appearing. Okay, shunya is void today. So in the Greek philosophy, this void was something which was to be abhorred. So the conditions, even in the Charles Saffe's book, so he tries to argue out why the Indian civilization could assimilate the idea of zero and infinity, okay, whereas why the Greek civilization could not. Okay, so this idea definitely evolved here, and the first text that deals with the operations of zero. So a into 0 is 0. So this kind of a thing, a plus 0 is a. This kind of a thing is Brahmagupta's work in the 7th century. But before that it has been there. We do not know exactly when it was brought into. But the origin is definitely associated with India. And the term that is used for infinity is Ananta. Ananta means unending. Literally it means unending. Okay. So in fact there is a verse which is given by Bhaskaracharya. Asmin vikara khaharena rashau. Any number divided by 0 is what is called khahara. Kham is space. Kham means akasha. Akasha is having nothing. Okay, therefore it is used for referring to number 0. In the Bhuta Sankhya, Netra is 2, Akasha is 0. Khahara means a number which has 0 as divisor. The word khahara means number which has 0 as divisor, any quantity. So whatever it is, that number is unchanging. That is what it says. Asmin vikaraha khaharena rashau api pravishteshvapi nisriteshu. Whatever you add to that, whatever you remove from that, that is going to remain unchanged. Okay, this has been there in some form even in the Ishavasya Upanishad. Purnamadah Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnameva Avashishyate. This is how the Ishavasya Upanishad puts that idea. So what we have to understand is initially some concept emerges and then you give a symbol to that and you try to do mathematical operations with that. There are 3 stages in which every idea evolves. Even when I see, initially there are 2 apples, right? I have a sense of 2 in my mind. So there are 5 apples. I add 3 more. So I have a sense of that in my mind. Then I try to give it a representation. Then I try to play around with that. 2 plus 3 is 5 and so on. So that is how it evolves. So the ideas which were fertile for the development of zero and infinity are there in our philosophy. Okay? And therefore one can say it were definitely evolved here, not in other places. Yeah. So you wanted to ask something?
Any other question? Yeah.
Sir, there are many YouTube videos where I saw that 3, 6, 9 are the universal numbers. 3, 6, 9 are the universal numbers. So on these 3 numbers, there are many YouTube videos. So they are saying that if you take some decision on these numbers, then there are the probability of success is very high. So is there any science behind this number, or it's just a blind belief?
What did you say? When you see these numbers, is it?
No, 3, 6, 9 are means there are many. There are in the internet I saw. There are in many areas I did mention that 3, 6, 9 are the universal numbers.
What does it mean by universal?
There are many people spoke in this number that I heard that Nikola Tesla was researching on this area. So it's blind belief or is there any science? I heard that when he used to clean the table, whether he'll use 3 tissue paper, otherwise 6, otherwise 9 to clean the table. So what are the things he'll do? He'll try to use 3, 6 or 9 in his daily life. So is there any research behind this, or it's just a blind belief?
Yeah, I don't think that one can associate anything special to these numbers. Okay. In fact, when you said this, I am just reminded of something which in my childhood, one fellow said, if you see 1749 in a car, then you will get something. I used to see every car. So whether 1749, whether 1749, okay. So these kinds of things are sort of, could be created for the sake of fun, for making somebody observe. There could be various reasons. But I don't see, as far as 369 is concerned, anything, okay. So special about that.
Thank you.
Any more questions?
Sir, actually, I'm asking whether you ever found any new formulas or new concepts which is already discovered by someone else that's in Vedas or in any in slogans, and that any new concept or in any new formulas that which is not already discovered by someone else. Have you ever found anything like that?
No, wait. Not discovered by someone else means, obviously even this which I was saying, at that time it was not discovered by someone else. Right? Yeah. Yeah. So I'll tell you, there are two aspects to it. As the ideas evolve, various things keep emerging. Even Newton's laws. So they are valid only in some frame. They are not valid in some other frame. So they become something which is relevant only to some part. So as ideas evolve, various things have to be considered as approximations. At one point you may say this is correct. At later point you will say this is applicable only to this domain and therefore it is. This is something which happens throughout. So when somebody discusses, I'll tell you, this is something which one can see in the technological world. Okay? So various things come up and the whole things become redundant. So today, having this button phone, that was something which was great, and then it has become meaningless. Today I don't know even how to operate this button phone, all that is happening. In terms of mathematics, for you, if the question were to say that have Indians found something which is unique and most optimal to do something which has never been done elsewhere in the world, the answer will be still yes. You understand? So there are processes by which you try to arrive at something. There could be a mathematical process to solving something. I can give you one example. There is one thing called Chakravala. It is solving a second order indeterminate equation. Tell me what is indeterminate equation? When will you call the equation indeterminate? Yes, tell. You should go. Feel free, what is this? When will you call in mathematics an equation indeterminate? Suppose I say 3x is equal to 5. Is it determinate or indeterminate? X is equal to 5 by 3. It is a determinate equation. When will you call indeterminate? I have one equation with two variables. Suppose I say 3x plus 4y is equal to 18. Can you solve this equation? You cannot solve. This is called first order indeterminate equation. X and y are variable. They are in the first order. It will be called as indeterminate equation. The first kind of solution, the first standard way of solving this equation was found by Indians at that point of time. Later other civilizations have come with some other method. So one can always say, suppose I have a method to do this, I have another method to do this. It is like writing a program. I can write it in C, I can write it in Fortran, I can write it in BASIC, I can write it in Python. Right? So the solve I have to solve this equation. What is the most optimal is what we will try to do. Suppose I have to do weatherproofing. So there are several methods by which I can do, which will be the optimal, which is the correct thing to do today, is one thing. So in solving this, there could be multiple methods, but there could be a method which is unbeatable. Even today, the solution that they have found is the most optimal solution. Optimal means you do in minimal number of steps, you get the answer. Okay? There are such things for solving second order indeterminate equation, which nobody has attempted. So Brahmagupta attempted in 7th century, and then it was further refined in 11th century, 10th, 11th century. Even today, the most brilliant minds like Euler, Lagrange, they have come up with some other thing after 8 centuries, 8, 10 centuries. But their method is something which is inferior compared to the method that the Indians have advocated. Okay? So if that is the kind of thing that you were asking, so there are certain ways of handling certain problems, and this is by far the best way. It is like even you are curing your body. Okay? So we came up with the idea that taking painkiller will immediately help me. So what has happened today? I'll tell you one simple thing. I went to Chicago 2-3 years ago. I had a friend who is an ENT doctor who has been successful, extremely successful. He sold his thing for $3 million, $5 million and so on. Extremely successful doctor. He had some back pain. So he told me, then he could not sit. I was asking, what is happening to you? So he said, there is something. Then I said, why don't you get this done something? He said, there are so many things which I know for this, but I have decided to live with this rather than go and then get this pain eradicated. I am neither consuming something, nor am I going to get operated because I know the ill effects of it. But most of us have just went ahead and then thought of finding some immediate cure for it. So there are various levels in which one has to think of what is the optimal solution for a problem that we are facing. It can be a mathematical problem, it can be a problem which has to do with the body, it has to be a problem which has to do with the mind. There are various things. If you have to learn to live with your spouse, you have to learn to live with your spouse. By quarreling, what do you get? So it is a maturity. So there are some things, so both in terms of medical field as well as in terms of approaching the problem, there are so many solutions which are very, very important to understand. So mostly to do with the life problems. So technologically one can find some solution, immediate solution. Whether the solution is going to be a solution which does not lead to a more serious problem is something which we have to understand.
Any more problem?
So, after hearing your lecture, I was having a small query or doubt regarding the fact that most of the things, or at least some of the things, which was developed by science or mathematics in a later stage, was originally developed in India. Are there at least many facts which are originally developed from India, which were maybe they have been found elsewhere and have been developed in later time by scientists of other places?
Correct. There are several such things. That's what I said.
Okay.
Even this pi series, which I was quoting, is a Madhava series. 3 centuries before Madhava found. But one should not immediately say that after 3 centuries when Gregory and Leibniz found, he simply copied from this. This is not correct. Unless we have evidence to show. But of course, I will tell you definitely for sure that whether the sine function or even algebra for that matter, we have evidence to show that it got transmitted from Indian continent to other places. So in fact, there are several brilliant people who have talked about the importance of the decimal place value system in India, which got evolved. So all of you know this Roman system, right? XX22, it means 22, right? So suppose I say 153. So you have one way of representation. C, X, whatever you write, right? Suppose you have only that notation for representing the number, you have to multiply 153 by 248. What will you do? I have that representation. I know a number. I find a representation for the number. Right? Suppose 153 means I write C. Right? So 100 for something, then 50 for something, then 3x 111. Then 248 you will do something. You write. You have to multiply this with that. How will you do? So this fundamental discovery of even the decimal place value system, which has enabled, there are so many people who have written on this. Amazing remarks have been made by sciences that this is something which is very, very, very far-sighted. So the decimal place value system, which has enabled us to do even computation, which has enabled us to move ahead with doing science, is an Indian contribution. So whether it was discovered elsewhere, we don't know. I don't think it has. So this decimal place value representation, what you have to understand, decimal system is one thing. We have a sexagesimal system, up to 60 they were doing in some other civilization. But giving a unique representation and a place value for a number, so is something which has enabled. So this has really made the science flourish. So this is one important thing that they have done. Okay. So and there are similar other things. Even this infinite series, it was found 3 centuries later. There are similar solutions, as I was telling you, second order indeterminate equation. Chinese have done something, Indians have done something, and Europeans have done something. Yes. But I would like to caution people not to claim that anything that has been found you find back. ये तो नहीं होता है. This is wrong. Okay. So everything is in there, Veda. I mean, this is not correct. In fact, Veda does not contain any of this mathematics. It is only the later text in Sanskrit which contain mathematics. So Veda purpose is different. Okay. This has to be very clear. Veda refers to a corpus of knowledge. So later Jyotisha represents some other corpus. Chandas Shastra represents something. So Shilpa Shastra represents something. The purpose of each of these domains of knowledge is also defined in the text. So that understanding has to be clear. And everything should not be put upon Veda. This is like putting a huge pumpkin on the crow's head, pigeon's head. ये तो नहीं होता.
Any more queries? No more queries. No.
Sir, question is regarding the sources. How much of the sources are available in the public domain actually? When we actually search for content related to Madhava of Sangramagrama, related to Madhava of Sangramagrama, we searched content and actually there was no reference to even the photo which was coming. There was no reference to that.
Yeah.
So
no. What you have to understand is this photo is something which is created by us.
Yeah. So
whether you want to draw Saraswati or you want to draw Lakshmi or you want to draw Shiva or Shankaracharya for that matter. So these are all something which have been created by an artist.
Yes. So
right?
Still, is it really?
No. That photo not getting, I mean, that is a simple thing. So when you say the text, so the texts are preserved in some libraries.
Yeah, actually,
in fact,
Yukti Bhasha, it is available in the public domain. In archive, it is there.
Yes.
But not other texts.
Other texts, that's what I'm saying. So there are hundreds of other works. Many of them are still in the form of manuscripts. And these manuscripts which were preserved by the individuals of those families or his own Sishyas and some Prasishyas, etc. So they have all been collected nowadays and put in some manuscript libraries. So there are several manuscript libraries which are there. One of them is the Trivandrum Manuscript Library. So this has a huge collection. And now what is happening is, I have visited this several times. Now even the Kerala government, has taken interest in trying to scan this and make it available in public. So that is going on. They have done hundreds of manuscripts they have done. So a few months back I came there and then I visited, and it is going on. And similarly in other places also today, this digital facility that we have today is being made use of to make these copies digitally available for people. So you have to just approach this manuscript libraries. So there are catalogs which have been prepared by people. I mean, these are all amazing scholars. So these scholars, I tell you, so nowadays everybody thinks, what is the benefit? Immediate benefit. Immediate benefit is not some money. This is a silly thing. I am just telling you. I am telling you, these youngsters, please take it from me. I mean, you will see that there are several people who just immediately got package like 30 lakhs. Soon after completing MT 60 lakhs package. I have seen all those students. Within a few years, that's all. They get completely drained. Okay? Because money does not give enough satisfaction in life. So this, you please understand this. So we have to live to achieve something in our life. This is very important. So it is in taking this trouble and getting something, you get immense satisfaction. Okay? So even these manuscripts, so these people have been meticulously preserving. Okay? Here to kya hai, iske mujhe fayda nahi, you just dump it. That doesn't really lead us anywhere. So we need to respect what has gone behind it, and anybody who comes across this should immediately try to do something what we can. And there are people who have taken special interest to catalog all of them. Study them is not easy. And they were just working for 300 rupees, 400 rupees, I know. Even 40 years before. Okay. So it is those efforts which have prepared catalogs. So catalogs are available. Catalogs of catalogs are also available.
Any more query? But sir, one thing that even though if we get this manuscript or verse, but difficult to understand, yes. Because like you have given that numbers like that represents 4, that represents 2.
Correct.
That is actually like it's not easy to understand.
Yeah,
even though it is in the Sanskrit also, it is not there.
No. See, I took interview of several people. They have difficulty even understanding a square plus b square is equal to c square. What do you do? I mean, if you are not familiar with that, yes, it is difficult. Yeah. Anyone who has not seen what is a to the power 2, forget about that. So suppose you take some fellow who knows only alphabets. So suppose you give the word together. He will read it as to get her. What will you do? So he will read listen. What will you do? Listen.
Yeah, so that's what there
my father says English is the most difficult language.
So before going to those verses and manuscript, some pre-requirements may be there.
Yes, I mean even I am telling you, I got training in Sanskrit from my childhood. My mother made me learn this Sanskrit when I was in 3rd standard or all that. So from 3rd to 5th, I just learned something and then I learned later. So with all that training, so when I looked at these manuscripts, it was difficult.
Yeah.
So that is why I said, when Donald Knuth, the reason for quoting that one of the most brilliant minds in computer science is getting to source work. It is not necessarily true of these manuscripts. You go to Newton's Principia. Principia is considered as one of the most important works in science. Newton's Principia. So you just look at that text, you will not understand ABCs. So today we have this d by dt and so on, some notation which we are familiar. And he would use some other term called fluxions and he will have his own notations. How will you understand? So any source work, even this representation of numbers I am saying. Today you have 1, 2, 3, I mean you have learnt in a particular way. Earlier they were writing in a different way. So that will be difficult for you unless you are used to it.
Yes.
So ultimately what we have to understand is, This is so easy when you say. It essentially means you have been repeatedly reading it and it has gone into your mind. That's all. So, easy or difficult has to do with the familiarity. Okay? So, if you are not familiar, everything will be difficult. But becoming familiar at a later stage is a little more difficult with respect to gaining language. So, that is why it is important, even this NEP, people should not oppose. My mother, I am telling you, she can speak so eloquently in 8 languages. It is all because she used to listen to those languages when she was young. So today we sign in 3 languages, if they learn everything will get confused. These fellows are confused, not understanding the potential of the brain.
Namaskaram. Sir, to be the better knowledge in the mathematics, should I do the course in chemistry or Sanskrit? Or without Sanskrit, can I do better in mathematics?
Wait. Mathematics is a language in itself. Whether you do in Tamil, or you do in Malayalam, or you do in English, or you do in French, mathematics is a language by itself. This is something which you have to understand. So when you study physics through English, through Malayalam, what are you studying? You are studying physics. Physics is something which is beyond this language. Language is used to communicate some idea. Is it clear? When I say 1, I have an idea of 1 in my mind. Whether I write it like this, or I write it in Malayalam, in some other script, or you write it somewhere else, that is a representation of an idea.
But sir, ancient invention of the math was in Sanskrit.
Wait. That's what I am saying. That's where I am coming now. Sanskrit was used as a language which was most convenient to represent what you had in your mind into the form of text. If you go to Greek, Latin, they were also doing mathematics. Euclid did mathematics. Archimedes did mathematics. Ptolemy did mathematics. They wrote in Latin. You understand? So, this using a language, you try to communicate an idea which is beyond this language. You first get? Yes. So, suppose you just say, give half the chapati to the other fellow. He has not learnt any script, anything. Does he understand half or not? In mathematics, what will you say? X by 2. Chapati's area is x. X by 2 should be given. I mean, this is how you will put it. Right? So, this is something which we have to understand. So, if you want to understand what has been done by our mathematicians, then since it has been written in Sanskrit, it is better to learn Sanskrit. And mere Sanskrit also does not help, as I told you. So, if you know English, can you understand physics? You can't. Right? There are so many books which have been written in physics which does not carry an equation. Right? So, the radius vector sweeps out equal areas in equal intervals of time. It is a statement. The radius vector sweeps out equal areas in equal intervals of time. It is a simple English sentence. What will you understand from that? So, now you have to translate this into mathematical framework in your mind. You get it? So, there is a misconception that people have that Sanskrit is difficult because I have not learnt in my young age and therefore what is there is difficult. There is nothing like that. So, the advantage in this text is another thing. Let me just tell you, since you asked this question, I am happy that you asked. So, we have lost this ability of quickly quickly formulating something in our mind as things are spoken. I went to Seattle a couple of years ago. Seattle, you know? Seattle. You know, where is Seattle? S-E-A-T. You know Texas? You know New York? Right? These are all places in US. Seattle is in the western corner. Okay? So that is the hot spot of Microsoft. Anyway, so now there I was asked to address a school gathering, teachers as well as students. So they were saying that our students have a big problem with word problem. Word problem means a problem narrated in words. This is what they said. I did not understand what is word problem. Then I had to ask him what is a word problem. Then he said that this is what is called a word problem. Then I understood that. So this is essentially the training that you have been lacking to formulate something as something is being stated. This is a serious problem, not only in understanding mathematics, even in following what others say. You should develop the ability to carefully listen and then translate into your own mind, which has nothing to do with the language. It is the idea that gets into the mind. Language is essentially some sort of a noise. Strictly speaking, it is some noise which is created. And this noise is interpreted by our brain. If I don't know Malayalam, I mean it is a noise for me. Nothing more. Some vibrations come and hit my ear, it gets into the mind, it does not get translated into any picture. So, that whether I need to know Sanskrit, etc., this is not true. How it is presented in the Indian tradition is what we are trying to say, and there are some definite pedagogical advantages in trying to present mathematics as it has been presented in our tradition. So this is what we have to understand, the significance. Exactly. No. It has to do with comprehension. The ability to comprehend something, this is very important. So if you get trained here, your mind gets a training to comprehend something quickly, which is the ability which is expected of a bright person. After all, life is full of problems. You should be able to comprehend, relate something and then find a solution. So it is the training that we receive which is going to help us, not the problem that we solve. That everybody has to understand.
Sir, I understood that great progress were done in the medieval periods probably. But what is your feeling why it was not happened afterwards?
Yeah. No. It is very simple as far as our comprehension goes. There are several factors which influence a progress in a society. One is patronage, the other is recognition, the other is lack of continuity, the other is suppression. Okay? So we have to just keep all this in mind. So why are we encouraging some child? When he renders a verse, you clap. Why? You try to boost the child, right? So this is something which we have understood as a mechanism which works for one to progress further. It is a recognition that we try to give. Now if in a society you have to suffer for your own day-to-day living, then your mind will not work. If you have been deprived from one way of functioning and then put into another thing, then also your mind will not work. I am telling you. So people who are so comfortable with C++, they will try to write in that language whatever problem that you give. If you are working in Python, so then you feel so comfortable with that. For you to move from this, so even though it may take some 10 more steps, I am so familiar with this, I will be able to go ahead and then try to solve that better. If you compel me to do something else, then you are deprived from your line of thinking, and therefore your progress will definitely be hindered. We have to understand. This, all of them added. If you look at even in the Kerala, the kind of societal problems that they had, okay, because of others coming and trying to suppress them, okay, giving all kinds of calamities were there. So one of the major problems that we find is there was no way but someone can think quite calmly sitting whatever he has been doing. This was a problem. Secondly, at a larger level in India also, what happened was these traditional ways of learning something, the traditional institutions which were helping people to learn the basic things, they were all disturbed. They tried to lay their hands, okay, at various levels. So there was no encouragement, there was turmoil in the society, and therefore one expects nothing but a deterioration. So I tell you that even most of the people, they learn the basics. So I was simply astonished by looking at a vegetable vendor. So when I was in my teenagers, I used to go to market, okay, 40 years ago. This person, he will be handling some 15 people. Each one will be getting some 5-6 items. For everyone he will calculate and then tell. This fellow will keep on doing his business, and then he say you have to give 17 rupees 80 paise. I used to do all this calculation, and then finally I arrive at this, whether he is correct or not. And he just does in a jiffy. Now even to multiply 40 into 2, some fellow has to take a calculator. So this is what is happening. So it is essentially, so this, the reason I am saying is, these basic arithmetic things were just taught in schools, and they could do this mental calculation so fast. It is a certain ability. And how does it help in various places? We don't know. So if a carpenter had to do all this quickly in a mental, this is how the people were trained to do basic arithmetic. But somehow, I mean, we felt that these are all meaningless. We have calculator, we have computer, and therefore, yeah, we don't remember phone numbers. Exactly. Yeah, it may come to a certain stage that you will not remember your own name. Exactly, that is why I am saying. Huh? Oh, some smoke is coming. You should switch off. Switch off the light, that's all. Yeah, exactly. Insect. Correct. So the thing is, we have to just understand that these are certain things which will work for us in a variety of ways, which we cannot be able to immediately relate. I mean, that's why I was very happy when he was trying to make a statement that meditation, etc. This is essentially a certain process which you will not be able to immediately relate. But this is something which has been sort of working and which helps you in handling various situations in your life. Okay? So, which is the most important thing. So, the short answer is, the society underwent a certain turmoil in a variety of ways, which hampered the progress of these disciplines. Neither the society at a smaller level could take care, nor the powers in B were favorable to this. They were only trying to disturb this. There are texts, there are records which are available even in the British thing. So this has caused a serious setback, really serious setback. And that's why we see the last 150, 200 years. So it has been a really bad shape. Even around the 19th century, in fact, there is a text by Dharampal, The Beautiful Tree, the Science and Technology in the 19th century. So which actually traces the details from the British records themselves and tells how the society has been a really functional society and a creative society. But that has been really disturbed. Unfortunately, I must tell you that some people, irrespective of the suffering, I tell you this, my own grandfather, when I think, I just can't marvel at the kind of dedication that they had. So my own grandfather, apparently, so he wanted to learn Vedanta at the cost of all sorts of comforts. So he used to walk 5 kilometers a day, get up at 4 o'clock, go. Even that 5 paise or 3 paise for the tram in those days was not there. And therefore he had to walk all the way. And he did not even mind making the family live with some kanji or whatever for a few days if that is not available. But I have to learn. So this is the kind of a thing that people had. So my grandfather had this kala. I have to imbibe and I have to see that it is my duty to transmit this kala further. So that kind of affinity that people had is what has made survive many of these kalas, whether it is music or dance or various other art forms. Today, I mean, we have decided to monetize everything. And that has had really bad effect, I tell you. You don't get good kalakars because everyone looks at everything in the terms of money. When once I had to really shout, I don't normally do that. It just happened in one of the meetings, in one of the apex bodies. They said that we have to pay for reviewing the paper. I said it is meaningless. So for reviewing a paper today you will say 500, tomorrow you will say 2000, tomorrow you will say 8000. I mean, where will it go? So certain things have to be respected for certain things. I mean, you are a scholar and therefore you are approached. That itself is a prestige for me. I should take pride in that. I can't take everything in terms of money. So this is something which is very bad. And therefore we have lost certain things. And everything is just looked from that lens today. And that has really taken the society back, is what I strongly feel. So kala ke liye, kala na jivan ke liye. This is how we have to work. Okay, whatever it is. Even when I study, I learn something, I have tremendous joy in that. What else can you think of giving you a better joy? That is why we have a statement in Bhagavad Gita, Nahi jnanena sadrisham pavitramiha vidyate. There is nothing like knowledge which can purify you better. I mean, it has powerful statement, it has various layers of meaning. But I just wanted to tell you, some of the students, etc., whether it is teachers or students, we should engage in gaining knowledge thoroughly. And there is tremendous joy in doing that. There is also tremendous joy in living up to values in life. Come what may, all the suffering will be giving you enormous amount of joy if you want to live for principles. I have seen this in my own life. in the life of some people who are close to me. Okay? So it is something which is to be valued. How to value values is what I think the education has to provide. Anyway, before the formal vote of thanks is delivered, I must thank your director for requesting me yesterday to give this talk. So I enjoyed. So it is only to audience, it doesn't matter whether it is 500 or 40 or 50. So it is the attentive audience which actually makes us feel. So I can see that many of these faces were quite receptive. So this has been a pleasure for me. Thank you.
Thank you, sir. So, respected dignitaries, Professor K. Ramasubramanian, our beloved Director, Professor Prasad Krishna, Chairperson of Indian Knowledge System, Professor Sridharan, our beloved Registrar, Dr. Somasundara, and our faculty colleagues, staff, dear students. A very good evening and namaste to all. So I will start my speech by just reciting the verse of mathematics. It is in the Jyotish Vedang. Yata shikha mayuranam naganam madhyotha tadvat vedang shastranam gartam murtam vartate. Murtam vartate. Yeah, both are there actually, sitam and vartate.
Wrong.
Okay.
There are several internet versions, this is a problem. Okay, so you have to get into the source. So this is a major problem today. Everyone feels like, he can write anything. So ये तो आजकल ऐसा हो गया.
Murtam istatam.
It has to satisfy metrical requirements. That is why I'm just saying.
Yeah,
It's not your fault.
Yes, sir. Correct. Thank you, sir. So the meaning is that like the crowning crest of a peacock, shining gem in the cobra's hood, mathematics is permanently positioned at the hem of all sciences. In Hindi, we will call that सभी वेदांग शास्त्रों के शीर्ष पर गणित उसी प्रकार सुशोभित है जैसे मोर के सिर पर शिखा और नांग के फन में मणि सुशोभित है. It is indeed a great pleasure for me to propose vote of thanks on this special occasions of today's invited expert lecture on contribution of Kerala to the world of mathematics. We, the team of Center of Indian Knowledge System, of course, team of Department of Mathematics, are sincerely express our gratitude for each and everyone who are listening this talk, physically or virtually. Professor K. Ramasubramanian has explained the contribution of various mathematicians from the land of God's own country, that is Kerala. He has beautifully explained the contribution of each mathematician in very elaborative manner. Sir has enlightened us with this talk, especially telling about a great Indian mathematician, Madhava. And sir, I want to just mention that in our department, a few years back, one of the seminar hall renamed as a Madhava Hall. And also we have prepared one poster. I think it will be displayed. Just I will be showing you there. Maybe you may get some suggestions in it. So it is indeed a great pleasure for all of us to his very informative and knowledgeable lecture. And just a few, I think in 2016, there was a Ragam program and Professor M.S. Raghunathan was here. And he has delivered a lecture on just a glimpse of mathematicians. It includes the Indian mathematicians. Professor M.S. Raghunathan, actually, he spent his time in Calicut also. He's a renowned mathematician in India. He chaired NVHM for a long period. So he was telling actually in his talk, just I will repeat the word, whatever he said that. Basically, the Carl Friedrich Gauss, one of the greatest mathematician, is said to be to have the claim, mathematics is the queen of sciences. And number theory is the queen of mathematics. So he was telling that, his own words, that he was asking a question to the audience that why it is said that it is a queen of sciences, why it is not said the king of sciences. Though he said that the king of sciences means that king is more powerful, why it is said the queen?
Even the king listens to queen.
So he actually said that, he only answered because we all audience were really surprised by this question. And he said that though king could be powerful, but queen is beautiful. So that's why he said that the mathematics is the beautiful things. That is why it is said that it is a queen of all sciences.
Queen drives the king.
That's true, sir. So, Professor, now we will talk that Professor Ramasubramanian lecture has explained the ancient mathematics in a very beautiful way. So I think, sir, whatever the way you have explained, it means we could not feel that the lecture is going for 1 hour or 2 hours. We are all totally devoted to the lecture, and we were listening each and every sentences, and we are trying to learn that. For example, when I am teaching the BTech first year student, my students are sitting here, many of them. I will tell about the calculus and starting from the Newtons and Leibniz. Because I was not having the idea that it has been given in the book, which is actually written nearby only in this particular state, Ganita Yukti Bhasha. So I was not aware about that book, and thank you that today onwards, whenever I will go, especially in the class, in the beginning, at least I can tell about this. And the series which you have given here, that you have said that just we learn those series in the form of that it is a Newton's Gregory series, because all the contribution which we are getting from the books always talk about the Newton's contribution, Leibniz contribution, even though when I am starting the differential equation. So I just gone through the history of the differential equation. It has been written that the first differential equation, that is known as the separation of variable, it was solved by the Leibniz in 1696. I don't know it was solved earlier also, even though by the Indian mathematicians, because sir has shown some equations. It is difficult actually. I am sorry to say that, but for me it was like to identify whether it is really a differential equation or not from our manuscripts. It is difficult. Maybe it is already solved. That's we have to work on. Maybe sir may in future again you may tell about that also, sir, about the differential equations that. So this is about the way that sir has explained, and I feel that the Carl Friedrich has given the statement after knowing the history of Indian mathematicians that it is the queen of sciences, because they have already explained everything in a very beautiful way. And just I want to say that sir has started that the Pythagoras, Professor Director also has said that the Pythagoras was invented much more earlier. Fortunately, my father was a teacher. Actually, he was a mathematics teacher, and he was telling that I think it is the 90s also in UP board. Actually, they have replaced the theorem, and they are saying that it is a Bodhian Theorem. So in the curriculum also, no more it is a Pythagoras Prameya. It is written clearly that it is a Bodhian Prameya. So because now our students will be understanding that this Prameya was given already by the Bodhian much before the Pythagoras. So if such kind of the things we can do in the curriculum, in the syllabus revision, then it will connect to the, especially in the childhood, to the kids. So they will easily understand. Still, see that when we teach, still I have studied that name, that Bodhian Prameya. But when I teach, exactly I will teach as a Pythagoras theorem. So this type of the things we have to make a change. So I don't know, maybe in future that has to be corrected.
Yeah, now the curriculum is being revised.
Yes.
So both at NCRT as well as there are other boards. So I'm engaged in that.
Yeah.
So in a few years from now, you will see a change.
Thank you, sir. Thank you. Thank you so much. So come to my trusted duty to give the proposed vote of thanks. So on behalf of NIT Calicut, on behalf of Center for Indian Knowledge System, and on behalf of the Department of Mathematics, fortunately I belongs to both the teams. And my own personal behalf, I express my heartfelt gratitude to sir, and I request all audience to give a big applause. It was really a very wonderful talk, very, very good talk. Means we were be connected from the beginning to the last to the talk.
Thank you.
I would express our gratitude to our Honorable Director, Professor Prasad Krishna, who has taken an initiative to establish this center and making this program, an arrangement of this program. Indeed, all of us are very much thank you to sir for motivating us towards our Indian knowledge system. Thank you so much, sir. So the man behind this show, none other than a very humble, gentle and smiling face person, Professor R. Sridharan. So sir has made all arrangement for this particular program, and also sir has immense knowledge of Vedic mathematics, astronomy, Sanskrit, many more. So we are all thankful to sir for organizing this particular event. Thank you, sir. I would like to express my sincere thanks to all of my faculty members, staff, beloved students who had made this event a great success. Thank you one and all. Just I will read the same sloka. Sir, yes. Momento, yes, sir, yes. So I would request to our director, sir, to give a token of appreciation, one memento to Professor K. Ramasubramanian.
This will be used.
Thank you, one. Jai Hind.